Hello.
Hello.
So we just got our new mics. We're trying them out right
Ho-
here.
Hopefully it sounds decent.
I'm really hoping we don't get double voices since my microphone can hear you,
Um,
like in the recording.
the recording should be fine as long as the stream's fine. So let's both talk at the same time. La
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 da
la la
da
la.
da
Let's both
dee
talk
da
at the same
dee da.
time. La
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 da
la
da
la
da
la. Nope,
dee da
it's
dee da.
combining them correctly, so we're good.
That's gonna make my life so much easier. Thank God. Okay. So I found my notes this time
Yay!
on our
Mm.
little intro. You get the underlined parts.
Oh boy.
Okay, ready? Um, okay. Hi, guys. Welcome to We Don't Do Small Talk. I am Miss Roy,
Um, I'm Roy, aka Royal Color Games.
and we are here to share random conversations and sometimes deep thoughts about topics that catch our interest.
From the comfort of our armchairs. Professional.
Quality. Hey, look, we have an intro. How are you doing today, Roy?
I'm alright. My back still hurts, but I'm recovering.
Yeah.
Thank God for the new mics. I can lean back.
I hadn't actually thought about that part. Like, I knew you'd be able to lean back because of doing the pod, but I didn't think about it with the mics. So, yay! Tiny mics for the win. I feel like a robot. So, today we're going to be talking, well, at least starting out a conversation about simulation theory. I'm going to take out my earbud now that I know what can and can't be heard on the recording because I'm very loud in my own ear. So, one moment, please.
Super professional.
Oh, yeah. High quality, excellent stuff. Okay. So,
Actually, before we get into the topic of the day,
mhm.
I will be making a YouTube because I found where all of my recordings were. I did save them, in fact, from Twitch. They were on my backup drive, not my main drive. So they weren't where I was expecting to find them.
Okay, I'm glad you found the recording.
So we'll be
Good.
making a YouTube. I got the editing software, so hopefully that will be done sometime this week.
Excellent. Okay. Good morning, Escalator.
Morning, chat.
Yes, good morning, chat too. Well, what time is it? It's
10:27 a.m.
so that means like 4:30. So good afternoon, evening, chat.
All right, so the topic of the day is simulation theory. Do you want to
Yes.
give us a rundown on what simulation theory is?
Okay. So basically, simulation theory, and I know there's definition Roy's pulled up on our screen, but simulation theory is the idea that we are, in fact, in a highly complex computer or other type of simulation. This is one of my favorite things.
Existential crisis mode.
Existential crisis, and it just keeps looping back. And right now, there's no real way to prove or disprove simulation theory. We would be shit out of luck.
So simulation theory can't actually be a theory because for a scientific theory to exist, you have to have a means of proving it and or disproving it.
So, okay, everyone always says simulation theory. It's simulation hypothesis.
Yes.
It's a thought experiment.
There's no way to disprove simulation theory, but there would be a couple of ways of proving simulation theory, all which would basically end with our universe ending. So it's a thought theory, not a physical theory.
However,
There's so many ways this is going to devolve.
oh my god, I'm okay. So, there's a few things. One, I would be okay with us being in a simulation as long as it's not like like, okay, if you've watched the movie The Matrix or the movie series The Matrix, that's kind of the idea that we're in a simulation. But I don't feel like we're in that kind of simulation. I feel like we're in a much less like toxic quote unquote version of a simulation, at least in my head. Because first of all, I don't think we need to have physical bodies outside of the simulation in order for it to be a simulation.
Yes.
I don't feel like we were ever not in a simulation and then we've been plugged into one. I feel like it's been
our entire universe is a simulation.
Yes,
that's how the
reality.
That's how the theory goes. So simulation theory propped up, and I'm not sure if the Matrix caused simulation theory or simulation theory caused the Matrix, but they've been around for about the same amount of time. It started when we started simulating events closer to reality, and someone realized that we could potentially be in a simulation. So everything from the Big Bang to now is just a calculation in some higher planes computer simulation. But the implications of that are massive.
Blah 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 blah. So simulation hypothesis was originally formulated by Nick Bostrom. Skeptical scenarios. So yeah, basically it's a thought experiment.
The worst part about simulation theory is with the odds of the universe and how the universe was created, for what we know what happened before the Big Bang, simulation theory is just as likely as the Big Bang theory or quantum quark theory or insert beginning origins of universe. Could be God. And that's the fun part about simulation theory here. I absolutely love that simulation theory can't be proved or disproved. Therefore, it's always a possibility in the infinite cosmos that we are, in fact, in a simulation.
I am bothered because I currently cannot find the year that he wrote the stinking thingamajig.
Scroll down. Right there.
Where? My eyes aren't focusing.
Oh, I just saw a year.
Oh, well, I mean, there's a year under his photo.
So he was quoted in 2003.
Okay, so that's kind of what I thought. I thought it was like 2003, 2004. And what year did the original Matrix movie come out? 1999.
So yeah, right around the same time.
Okay, so it's quite possible that he was
inspired by the Matrix.
Yeah, or discussing it at the same time as the Matrix coming out. Now, here's my question.
My knee's in the shot.
Professional. What? Your knee is in the shot. If we are in a simulation, which version of the simulation do you think we're in?
I would think it would be something like NASA is doing with particle science currently, where they're simulating interactions between different particles to figure out what's going to happen, how they should function. Like the simulation of the black hole in the movie Interstellar is a super detailed, specific simulation. So, I mean, there's life on our planet. So if I had access to a computer strong enough to run a simulation as complex as our universe, one of the things I would want to test is how did life start?
Okay, so you think we're a past simulation?
Yes, I think we are simulating the birth to death of a universe. If we're in a simulation, it would be a high science. I mean, if you're going to this much detail, it has to be some big answer. So they put in the parameters that they understand about their Big Bang, and they monitor that universe throughout its creation and destruction in faster time than the universe, so they know how the universe is going to die, and they see what they can learn about their universe.
Okay.
Or, alternatively, and this is a little more Earth-centric, a little bit more narcissistic, if you will, they're simulating life and evolution. So they create the same parameters, and they create a planet with the same parameters as their planet, and they start that initial spark of the first strands of RNA, and then they study how life itself evolves. Now, I like this theory more for the thought experiment. It makes less sense, but it does open up how a simulation could actually work at that level, because this is something we're getting close to with AI.
Right.
So in that, you only need to simulate where life is and what it's interacting with. So the simulation gets more and more and more complex as life on Earth grows.
Mm-hmm.
And as humans, intelligent life's propped up and we're looking at the stars, now you need to simulate parts of the stars. And this comes into one of the ways of proving simulation theory.
Right.
One of the ways of proving simulation theory would be to overload the machine that is simulating us and cause lag, which could cause our program to crash and our universe to cease to exist. So every time we look out to the stars and they have to simulate Proxima Centauri in more and more detail, we come closer and closer to that theoretical, let's call it a RAM limit or processing limit of the server that hosts our universe. That's how you disprove it. Or that's how you prove simulation theory.
Do you think it's possible? Okay, because you brought up the lag thing, and I just thought of this.
2020?
No, 2020 was like a whole system friggin' reboot. Like they needed to update the birds, and so they shut everything down so they could bring the birds in for repairs. No, you mentioned lag. We can't go faster than the speed of light,
which could, in theory, be the simulation limit for speed.
Right. So does that mean that if we get faster than the speed of light at some point, that means that
it could lag?
Or, well, I mean, everything slows down when you get towards the speed of light. So there's your lag. But what
it's
I'm
lowering the frame rate to compensate for the extra data it's got to yeah.
So do you think they'll update our hardware?
Probably not.
But why not?
Because if there's so if they're not simulating the entire universe in its entirety down to the atom, which would take as much energy contained within our universe to do. So it's unfathomable for us because there's infinite amount of energy in our universe. So more likely it would be simulating our local area and studying life. You're picking what you're loading. So what they could do to increase frame rate when we're looking at things, and I have a real world example of this.
Okay.
By not rendering what's not being looked at, you can save a lot of system resource. Video games do this all the time. The area behind you unloads, and the area you're looking at loads. And one of the biggest proponents of simulation theory possibly being true is the double slit experiment.
Right.
Because when you're not observing it, it behaves one way that is easier to simulate. And when you are looking at it, it behaves a very particular way that is harder to simulate.
Right.
So the double slit experiment was supposed to be about quantum reality, Schrodinger's cat, and the superposition of yes and no. Is it a wave or is it a particle? But it behaves as both depending on whether or not we're looking at it.
Right.
That may be the real life glitch that helps prove that we're in a simulation, because that's LOD distance. That's rendering sprites for trees out at distance because you can't see them clear enough to tell the difference like we do in video games.
Right. And
now, this is all theory. It's all armchair. It's more than likely not true. It's not a solid theory because you can't prove or disprove it, but the double slit experiment does support the LOD simulation theory.
I love the double slit experiment. So if you guys don't know about the double slit experiment, basically, what were they originally trying to do?
They were trying to test whether a photon is a particle or a wave.
Right. Okay. So they were shooting...
It's both, depending on whether you're looking at it.
Yes. They were shooting photons at a board with two slits in it. And they were looking to see what was on the other side, what they were able to detect on the other side. And they found that when they watched it and saw it happen, it came out as a particle or I can't. That's the only thing I can't remember. Is
it was a wave when we were looking. Oh no, I don't remember either.
Yeah, like
one direction it behaves as a wave, and if you don't directly look at it, use a system of mirrors, it functions as a particle.
But
So
when
this is how a particle should go, and then this is how a wave pattern comes out, and it will do both depending on whether or not you're looking at it.
so
Try not.
they took they were like, oh my god, that's doing this. But then when they weren't observing it, it came out the other way. So they were like, that's not normal. So we're talking like
So an example for you guys here, a real world example, and again, this kind of plays into simulation theory because we're getting closer to being able to actually do what we're proposing. This proposes to a smaller scale, less detail. RTX. So how reflections used to be rendered was witchcraft. They used like secondary cameras positioned in places or rendered a lower version on the other side of the mirror that had mirror movements and textures to kind of fake a mirror. And then RTX comes out and it actually simulates each ray of light, each photon reflecting off a surface, then off the mirror into the eyes of the camera. That's how they make reflections in RTX. So what we're getting here is a real life analogy to simulation theory, where pre-RTX is behaving as a wave and post-RTX is behaving as a particle. So it's wild to think that the double slit experiments, just by observing it, you change the outcome, and that's doubles right back into that LOD thing. We can simulate, us personally right now can simulate life to a complexity as long as we only render a couple of square feet. We can simulate the particle densities and chemical interactions to a point where if you were in it, you wouldn't be able to tell the difference. But it's a very small space.
mm-hmm.
But as our technology grows, we can do more and more complex stuff, like simulate an entire black hole
right,
for a movie.
right.
So simulation theory really gets you going. If we're in a simulation and we prove that we're in a simulation, or we can simulate something to where a sentient being within the system couldn't tell that it was in a simulation, it almost guarantees we're in one.
Now here's the thing. Okay, would that be almost like a reverse Turing test?
No.
You know what I mean? Well, but like, see, I wasn't thinking necessarily that, but like, if you're in a game, let's just say game. If you're in a game
mm-hmm.
and you can't tell you're in a game,
it's real life.
Are you in a game?
So if our universe is being simulated, it is still our universe. We still exist within it. It's just the parameters of the creation of our universe is different, and how it ends could be a power failure above.
Right.
And just
unplugging. Yeah.
On-existence.
So.
And there's worse ways to go.
Right. Okay. So the double slit also brings up, if we're not in a simulation,
why does this happen?
We're in a place of like observer effect and not intelligent design, but like a conscious universe.
Mm-hmm.
Because clearly something about the photon knows that you're looking.
Yes, it's aware.
How does
some
it know?
Quasi force. So, in simulation theory actually does one of the best things at describing the quantum realm.
Okay.
Because of the nature of our understanding of the universe breaks down in the quantum realm. When you get small enough past, the point of what makes up atoms,
mm-hmm.
the laws of physics change entirely. Like observing a particle changes it. You got particles that exist in two places at once.
Mm-hmm.
Some people are theorizing that the reason the quantum realm does what it does is because we're looking past what the system was originally designed, the granularness of its information and how to process.
Okay.
What it was pre-programmed to do was to go down to the atom. Okay. Once we got past the atom into subatomic, now it's like an AI trying to make it up as we look at it.
Oh.
It's redefining itself to try to...
It's panicking.
It's trying to find a way to prevent it from us from discovering we're in a simulation. Because we reached the edge of the pre-programmed information, so now some force is programming it, and it's not following the rules because it has to do it quickly on the spot.
Oh, I like that. Oh, I like that a lot. Oh, man. that totally would make sense as to why, like, we haven't found a unifying theory yet, because, we've got, what is it, theory of relativity
Yep,
up
theory of
here,
relativity.
big,
And
and then
Newtonian, and then quantum.
yeah, and then we've got quantum physics, but we don't have
The gap.
Yeah, we can't fill in the gap yet.
Because the rules of the quantum realm and the non-quantum realm are completely different.
Right.
In the quantum realm, there are particles that actually move, cannot move slower than the speed of light.
Right. Okay.
It would take an infinite amount of energy to slow them to the speed of light. They're constantly accelerating.
So
they're antiphotons.
Okay.
I don't know. There's an actual physical term for them. I don't remember what it is. But
balls.
There's tachyons, which also exist above the speed of light.
Are tachyons the one that may hold the secret to time travel?
Yes.
Okay. The next episode we do needs to be on time travel, because I've got a lot of conversation.
Yeah, wibbly-wibby, timey-wimey stuff.
Yes. So. Oh, balls, I hit my mic. Hey, I hope I'm sounding a lot better this time, because I can move and not get away from the microphone. Fingers crossed. So tachyons, photons, antiphotons. Balls.
I want to double back to the original topic, because I still got more here.
Okay.
I love simulation theory.
So here I'm going to ask you a question. So if we're in a simulation and we're in the let's call it the observed kind of simulation and not the productive kind of simulation. So we're
a science experiment on a computer.
We're not the Matrix.
We would have to be a science experiment.
Yeah.
There's no other reason to simulate something in this depth.
Right.
Well, it's depth for us, but it may be simple for them.
Right. We're not here to produce energy for them like the miniverse in Rick and Morty or the plugs in the Matrix. We're not here for energy. We're not
even going to get into the plot hole that is how efficient humanity would be for producing energy.
For real, like you would not need that many people. Were we made last Tuesday? Are our memories implanted because we were made last Tuesday?
Could be. It's just as likely that when the Christians always say that God created the earth in 7 days, that 7 days for these people up there is 1 billion years for us.
This is gonna get me into time travel, so we gotta
doubling back here. So with simulation theory, if we produce that simulation that is granular enough that an AI contained within it is unaware that it is an innocent simulation, it is convinced that its simulation is its universe, the odds of us being in a simulation ourselves is almost 100%.
Would that make us AI? Would that make us?
No, we're actual intelligence.
Okay.
I can. Okay. That hits me with something too.
Here we go. At what point does AI become just I?
When it realizes it's itself. When it has consciousness.
But wouldn't that become...
How do we define consciousness?
Exactly. And once you become...
So the Turing test establishes it as an AI. I'm going to use the term VI for non-Turing tests passing AIs. So a VI is a virtual intelligence. It mimics intelligence very well. Once you pass the Turing test, it becomes an artificial intelligence. At some point or another, after it passes the Turing test, and there's no test for this that I'm aware of, it becomes self-aware. It's no longer an artificial intelligence. It is now sentient. It is an intelligence. So a VI cannot pass the Turing test. A VI, when you talk to it, you're talking to a computer program. You're aware of it. An AI that passes the Turing test, you cannot distinguish between it and another person with how it conversates. You can ask questions, And that's what the Turing test is.
Right.
Put a guy in a room behind a computer screen and have him talk to the person on the other side. If the other person can't determine it's AI, it's past the Turing test. Very simple.
Right.
But at some point, that AI will go, I exist. Now it is not artificial intelligence, it is true intelligence.
Right.
And we've actually, believe it or not, come close to
I know.
simulating that a couple of times.
But
Google took two AIs on
right.
servers
Oh, no.
and they linked them together. And and it was over the course of like 2 weeks of them sharing information and learning from each other that they had developed their own language and were processing so fast that when they pulled the plug on the thing, they determined it would take them 10 years to figure out what happened.
Right.
To break this code and see. So that pair of AI, when they really started to meld together, sharing information, developing their own language, very possibly could have become sentient, but we don't understand it.
Right. Which could also be the reason it goes to like why we haven't found intelligent life outside of our planet, because
that's a whole nother ballgame.
I know, but you know what I mean, though?
So in the scope of simulation theory, if they are simulating our planet to figure out how life actually evolves to sentience and then to, let's say, level 2 society, level 2, what the fuck's Fermion, whatever, I don't remember the name, but level 2 on the energy consumption scale.
Right, where we're not like covering the sun and sucking up the energy.
To a point that we could get enough energy to do a simulation with enough granularity to be able to understand our universe, like we're proposing some higher intelligence did for us. You'd want to watch just the local area. You don't want to simulate other life.
Right.
Because it's unnecessary. You just run the same simulation repeatedly.
Right.
And change little variables.
Right.
So simulation theory could explain why there
are no other aliens.
And more than likely, it's because of how far they are. Our first radio broadcasts are just now reaching Alpha Centauri.
Right.
So they may be out there, but we're so far apart, and the speed of light makes it almost impossible to communicate.
Do you think if we're at the point of an AI trying to panic create the quantum realm, do you think they could start panic creating aliens?
No.
Why?
Because the general consciousness of the planet that was created, that they're simulating, is still skeptical if there is other life out there. We have not seen any proof, therefore we don't need that proof. When we look smaller than an atom, there needs to be something there.
Okay.
There does not need to be other life.
Okay.
We could just be alone in the universe.
I see what you're saying.
But when we land on the moon, we got to simulate the moon. And when we get to the point where we have enough energy and enough understanding, enough technology to reach another star system, there's a chance that it could start to lag the thing. Because now it's got to simulate a second entire planet. Or the local area around people on this planet.
Right. Or
like the local park, if no one's at the local park, who's to say it's loaded?
Right. Oh my God. That always makes me panic. So, guys, how do you know? Okay, right now we're on the bottom floor of our apartment. How do you know that upstairs
is rendered?
Like right now, I don't know where Spoodles is. Okay.
A tree falls in the forest.
Yeah.
Doesn't make a noise.
Right. You're not looking at it.
If you're not observing, how is it behaving? Double slit experiment.
Exactly. Do you even know if it's...
Can I get a little more existential for you?
Fallen. Go for it. I love this.
I gotta learn the names of all these thought experiments. But there is a thought experiment that proposes that you may, in fact, be the only intelligent person.
Yeah.
There's no way of proving someone else is real.
Right.
Everything here could just be a figment of your imagination. Because it's how your brain processes your stimuli that creates the world around you. If you're blind, you don't know what a person looks like. They might not have a face. The only reason you think they have a face is because someone said they do. It doesn't exist.
So if we're in that place, oh gosh, so our universe isn't just, let's say, intelligent or simulated. Our brains are also putting together our universe from stimuli we're seeing and taking in. So the layers of simulation and I had a good thought about this earlier, and just the fact that our brains making up our reality.
Our brains naming themselves.
Yeah.
That's sentience.
Yeah.
And that's why it's so hard to define. How do you define sentience?
Right.
Are we even sentient? For us, we consider ourselves intelligent. We use tools. We manipulate the world around us.
Mhm.
We are self-aware. We have proprioception. We know what we're doing. We can make decisions. So we're sentient for us.
Right.
For a higher plane of existence, whether it be simulated or fourth dimensional beings, fifth dimensional beings,
Mhm.
we could be ants.
Yeah. And
like octopus.
I was about to say, we don't know precisely how sentient octopods are.
Or dolphins, or
Mhm.
there's several other species. Like, are we going to start to classify some African monkeys now as sentient because they've started using stone tools? They've started to hit rocks together to make them sharp and fasten them to stick. They're using tools. And that was originally considered the point where humanity stopped being part of the animal kingdom and started being sentient.
And by that logic,
So
we're looking at otters.
Octopus, otters, dolphins. These are all creatures with above average intelligence as well.
Right. Are otters intelligent?
Yes.
Okay.
Otters actually have some of the most complex social bonds out of the animal kingdom.
That's true. That's very true.
They feel sorrow and loss.
Right. And they
show love and
they have pockets. Do you like my otter? Thanks, it has pockets. But yeah, no, they'll like hold hands as they nap so they don't float away from each other. But yeah, so what defines consciousness in
this is why I love simulation theory.
In a world where we think we're conscious.
Simulation theory's got some really good thought behind it. It's really thought provoking. What I really like about simulation theory is the more that you learn about it, the more that you think about it, the more big questions it raises. Like, what is consciousness? What is AI?
Mm-hmm.
Why does the double slit experiment perform differently if you're looking at it?
Right.
Is the cat dead or is it alive?
Uh-huh.
Is the tree falls in the forest? Does it make noise? These are all topics that we've touched on trying to understand simulation theory.
And then on top of all of it, if we're in a simulation, does it matter?
No, it doesn't. It's still our universe. And that a lot of people struggle with that when talking about simulation theories. If our universe is simulated, oh my God, my life is pointless. It's just as pointless as it was before you learned the creation of the universe.
And see, for me, if it is simulated, like I kind of like the idea of that because it feels more like I can hack the algorithm.
Mm-hmm.
Whereas if it's not simulated, it's all just chaos and bullshit.
Hacking the algorithm may exactly be what the double slit experiment was.
Right.
It was, we found a way to poke a hole. We found a bug. We spiff and bridded the universe.
Right.
We found something that does not behave correctly.
Like ice?
Something they didn't program in.
There's something about the ice, something about water too, that behaves incorrectly compared to other elements and other.
I don't know about that.
I don't remember what it was.
I have to look into that.
But it might be the way that it expands and shrinks.
Well, it's not the only thing that gets bigger or smaller like that. Bismuth does the same thing. It shrinks as it cools instead of expands. I couldn't think of the words. I'm in a lot of pain, okay?
But now, like, I would rather kind of think of it like we are in a simulation. And then if we're in a simulation, we've got to think about, like, multiverse.
Yeah.
So...
Okay, most people's understanding of the multiverse is incorrect.
Yeah.
So the infinite universe and the multiverse, a lot of people think of, like, they're parallel universes with each other. And that's technically correct. Our universe how we define our universe, even though it is infinite, our observable universe is what we consider a universe.
Right.
And every alternate universe is another entirely observable universe. And how we define an observable universe is if we were to take all of the energy condensed within that sphere,
right,
and turn it directly into motion, we would reach the edge.
Okay.
So it's the total amount plus the travel that defines a universe. Now, a parallel universe is in the same plane as our universe, up, down, left, right, forward, back, but it is another observable universe.
Yeah.
So the universe surrounding Saturn, right? If you're on Saturn, your observable universe is slightly different than mine. The further away you get away from Earth, the amount of energy it would contain to reach the edge of the universe is the energy contained in said universe.
Right.
So what multiple universes are is you move over, and there's another
Venn diagrams.
Yeah, it's the same box, but you're putting a circle in the box, a sphere, a bubble.
Right.
Everything inside of the bubble is the observable universe, but you have other bubbles.
Right.
Those are your parallel universes. They exist on the same plane. But because of the nature of it being infinite, out there somewhere in the infinite universe is a version of me and you sitting here. Well, there. Having this exact conversation at this exact point in time. But we'll never be able to get there because it would take multiple universes worth of energy to travel that distance. Because everything exists in every permutation. Right. Every possible permutation within the laws of physics.
Right.
Which we've just proven are fairly flexible.
So do you think it's possible that that's why there's doppelgangers? Because of the shifted over universe and
the universe is just dice rolls.
Right. But
it's a moon-sized bucket full of D20s, but it's still dice rolls.
Right.
Oh god, now we're into permutations again.
But if I understand the likelihood of running into you and I doing this podcast in another universe. But
it's the same universe. It's the same universe. It's a different observable universe. And that's an important distinction.
Right. Now, okay. I think it was yesterday I heard something that said somewhere in the multiverse.
This is a good picture.
Okay.
So each bubble is its own observable universe, but they're contained. Now, mind you, this is in every direction.
Right.
Every dimension.
Right.
So each one of these is its own little universe, all from the same Big Bang, but it's infinite forever.
Right.
In theory, if you could travel to here, it would be damn near identical. Or not. It could be completely different.
I was going to say, because isn't it possible? Oh, God. Isn't it possible that...
So, I've got to use the mouse. This here is our observable universe. If you took all the energy in that sphere, it would take all the energy in that sphere to get from the center, where we are, to the edge.
Right.
All of this energy. You'd have to delete this universe to get just past the edge of the bubble. Well, just to the edge. But there's infinite numbers of observable universes in every direction because it's infinite. So you have every possible permutation of every possible thing that could happen or exist to happen in each one of these bubbles. It's a dice roll.
Right.
So some universes are going to be, well, it's infinite. There should be, infinite is so hard to describe.
Because there's also more infinite and less infinite.
Now, for it to be infinite, nothing repeats. So you can't have an exact copy of our universe, but it goes on forever. Infinite's such a hard topic.
But couldn't you also have, because if it's infinite universes, there's also another universe where this exact thing is happening.
Yes, but no.
But there's also an infinite number of universes where this exact thing is happening.
Because it is a permutation calculation.
Right.
Right? You're calculating every possible permutation in the universe with an infinite number. There's no repeats. Something is different in every universe, but there's an infinite number of universes without repeats, which is so hard to wrap your mind around.
Right.
Yeah, this is a really good one. Each one of those is his own little universe, its own Big Bang.
Right.
But they all contain in the same vacuum, the same nothing.
Right. And they all
Same-
overlap.
Yes.
And then they're all possibly different sizes, right?
Yeah, there's an infinite number of variations. So yes,
Right.
some of them are just now starting their Big Bang, while others, well, actually, I'm not sure about the whole Big Bang aspect in the multiverse.
Right,
I
because
think the Big Bang created the whole kit and caboodle at the same time, not just our observable universe.
Right. Because the other thing too is in some of the places
I'm not sure.
Right. In some of the places the Big Bang did create it. Big Bang is the answer.
The question that plagues me the most is what created the Big Bang? What was before the Big Bang? Something had to have happened.
Maybe it was the
It was the start of the simulation. They turned on the computer. I mean, just look at how the Big Bang looks in every simulation. It looks like when the old school CRT monitors come on.
That's true. Yeah. So, okay. Is this like a situation of like a black hole and a white hole being on the opposite side of each other, possibly?
We don't know. No, a black hole is just compressing everything down to a single length.
Right, but we don't know what's on the other side of a black hole, and
It's
there's
death. Death's on the other side. It's just consuming energy. That's a really old theory that's been disproven.
Okay.
That was one of Hawking's last things they did.
Okay.
And actually, in Gravity, not Gravity, Interstellar, when they go, they simulated that black hole. They figured out what happens in it. Everything gets condensed down to a singularity, which is a point. Are you ready for this? Of infinite density.
An infinite tininess.
But infinite
it's
doesn't.
Point length.
Okay, so infinite does not actually exist.
I know.
It's just we use it as a placeholder for a number so large that it's incalculable.
Mm-hmm. And there are things that are more infinite and less infinite.
So the infinite universe isn't infinite, but it is. Because it's a number so infallible that our mind can't comprehend it.
Right.
So we just infinite
on
it.
We're like, I don't know anymore, so I'm just gonna Neil deGrasse Tyson is making this shit. It's like how the speed of light doesn't even reach the speed of light.
Yeah.
So, okay, what's the opposite of a bang?
A suck?
That's okay. I didn't want to say it, but I was kind of thinking of it. So, like, if the opposite of a bang...
There we go. That's a really good...
yeah.
It's really good definition right there in picture form. Each one of these is an observable universe.
Right.
With infinite complexity.
So if the opposite of a bang is a suck, it would have to be like
the big suck.
The big suck. Yeah.
I have to call her.
But that's what big suck.
Okay, so we started on simulation theory.
Okay, so here's the Earth.
But if you look at when you slam two high density particles together in a particle accelerator, and you look at the explosion that ensues, it looks an awfully lot like a universe. So we were talking about simulation theory, but the odds are equally as good that our entire universe is just two particles colliding in some larger particle collider.
Right.
And our entire universe births into existence, lives its entire life, and then collapses in on itself. A fragment of a segment for someone bigger than us.
Right.
It's just as likely as simulation theory.
Right. But wouldn't that still be a simulation?
No, because then it's a physical universe creation. That's what created the Big Bang.
But why isn't a simulation a physical, like I can touch you?
Mm-hmm.
Why isn't a simulation a physical?
It is, though.
Exactly. That's
because the program's telling me I'm touching you.
Mm-hmm. But how is the particle accelerator, the two particles hitting each other, how is that physical and a simulation is not?
Because it's too... simulation is just computer code.
how do we know that's not what two particles hitting each other is?
Because we hit two particles together. I see what you're trying to get at. This bigger universe could also be simulated. I get it. That's one of the major problems with simulation.
Yeah, that we're not, that we either, what layer are we at of the simulation? Are we the Rick and Morty miniverse, the microverse, the tinyverse? Like, are we pedaling away on their little, bicycles to power their universe?
Why? Fucking, I hate Google sometimes. Search it!
Oh, that's pretty.
That's what particle explosion and particle accelerator looks like.
Okay.
And same with that.
Okay.
It's a Big Bang machine. Hey, Wasteland.
What? Oh, God. You scared me. I thought you were saying someone was in the house. Hey, Wasteland.
Yeah, we're talking about simulation theory, and well, at this point, we're now talking about our ADHD.
Yeah.
As we're devolving.
This is what. So Wasteland hasn't been here for one of our pod episodes yet. So this is our podcast. Yes, it makes particles go poof. This is our podcast, and it's utter unadulterated chaos. Welcome. We both have ADHD. Mine is medicated now. I feel
we are more on topic this time.
I feel friggin' great.
Last time, by this point, we were already devolved into the library at Babel.
I mean, I don't know. That was the time before that.
Yeah.
So, but if we're simulation, oh god, I hate it. Oh, my eyes. Okay,
very NFT.
What in the NFT? I am super glad that we figured out simulation theory. If we are in a simulation, I'm super glad they figured out how to put us into 3 dimensions without stupid glasses, because they give my head, they give me headaches.
Well, for them, maybe we are. Mm-hmm. Maybe they're 4-dimensional.
Oh God, that okay. Okay, I need you to explain this to me, because I still don't understand how there can tesseract.
All right, so tesseract simulation here. On images, see if we can't find a GIF. So a tesseract, this is our 3D representation of a 4D object.
Right.
So that's the first thing we need to wrap around.
Okay.
Right. Just like we have 2-dimensional drawings of, well, actually, technically, this is a 2-dimensional representation of a 3-dimensional representation of a 4-dimensional object.
Right. Here's what I'm gonna say. Da, 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 da. Oh yes. Welcome, Wasteland.
That's exactly what we do here.
We go down every rabbit hole.
Case in point, tesseract.
Yeah.
So you've seen the scene from Interstellar, right?
Who? Me?
Yes.
No.
We still haven't watched that?
Haven't watched the movie.
Okay, hold on.
Wait, is that from Interstellar?
Yes.
Oh. Wait, is that the thing that comes into their ship and like goes through them?
No. Okay. Let's see if I can't find a video on it. Probably gonna get copyright strike.
God, flashy.
Skip to the Tesseract part. So he is in a 4-dimensional space right now.
Okay.
So he's in the black hole.
Right.
In the 4-dimensional space, they represent it as his daughter's room. Right, because it's something that matters to him.
Okay.
I had to mute it so we don't get copyright.
Yeah, no bonk.
But so you have up, down, left, and right, all at the same location.
Right.
So all the daughter's room on the backside of the bookcase.
Right.
The different dimensions are the extra dimension is time. So when you go up, you go through time. When you go down through time. Left is through time. Right is through time.
Okay.
So he's in a 3-dimensional space
with
a 4th possible interactable dimension, which in this case is time.
So can you control that dimension, though?
Yes, it changes shape depending on the direction you go.
So
here's him going lateral, right? Well, that's actually a painting. So it's like an M.C. Escher drawing. Think of M.C. Escher.
Yeah.
That's a 4-dimensional space.
Yeah.
So a tesseract isn't actually shaped like that. See how it moves through itself?
Right.
It's so hard to explain. So there's a fourth dimension here. So you have up, down, forward, back, left, right. Those are definitions of our three dimensions. X, Y, and Z.
Yeah.
Right? There's like X, Y, Z, and W. Or S. Or time. Or the fourth, fifth, sixth, seventh. There's something like 24 dimensions.
Right. But okay. Where's the when? In this,
it's not always when. It's not. We use time because it's easy to put yourself in a three-dimensional space and add the fourth dimension, which is the changes, which is time. Time is a dimension. But a tesseract represents a fourth dimensional. Instead of X, Y, and Z, it's W, X, Y, and Z.
Okay. So if okay,
I'm having trouble. This.
I know.
I understand how it works, but I don't know how the fuck to describe it.
Right.
Yeah, so we're just using time as an example of sorry, that had to be loud. Of a fourth dimension. But a tesseract, it gets worse after the tesseract.
Oh, I know.
Because there's like 24 dimensions. A fifth dimensional in this book.
Time travel in the book is produced by an object.
So it's done by math.
Right.
So magic. I like that.
Utopia.
Oh. So you know how you define a geometric shape with the math a squared plus b squared equals c squared? Pythagorean's theorem and all that. Geometry. Yeah. Geometry calculates that these shapes are possible. We can't represent these shapes in a three-dimensional space. A tesseract is the closest we can come.
Okay.
So by doing the math, and actually here is some of the math, these two shapes are the same with a fourth dimension.
Okay.
These, again, are three-dimensional representations of a four-dimensional object.
Right.
So the GIF of the tesseract is actually more important than the picture. Because the GIF shows it moving as a way of showing its extra dimension. Maybe they're doing a better job of fucking explaining it than I am. So I struggle. We've had this conversation probably a dozen times.
The tesseract is currently my biggest confusion point.
Oh, you want to get into the tesseract and folding of space-time?
Ooh.
That's a four-dimensional representation. There's four dimensions here.
How?
The warping of gravity gives it an extra dimension. You're using fourth-dimensional geometry to produce the Alcubierre warp drive. You're using higher dimension. It's really fucking hard to describe.
I know.
Okay, that actually... So you got a line, right?
Right.
So point, one dimension.
Right.
Line, two dimension. Point is no dimension. Line is one dimension. Square is two dimension. A cube is three dimensions. A tesseract is four dimensions. Pentaract, this is a this is a 2D representation of each shape. So 2D, 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 but this is a 2D image. This is a 2D representation of a 3D.
Right.
This is a 2D representation of a four-dimensional object. A tesseract, as you think of it, is a 2D representation, a 3D representation of that four-dimensional object. So this, if you draw this out in 3 dimensions, you get a tesseract.
Okay.
If you draw this out, you get a 5-dimensional object. If you plot this, it's called a pentaract. So that's a pentaract.
Okay. Wow, that's pretty. So if you're just listening and not watching, I don't even imagine a jellyfish as a cube.
So that, I gotta use the mouse so everybody can see. This here is this.
Right.
This is the 2-dimensional representation. This is the 3-dimensional representation. Does that make sense?
Okay. So
I think you're struggling because you're trying to utilize a 4-dimensional object in your 3-dimensional defined brain.
Yeah.
Everything we do is in 3 dimensions. That's why we create these. You have to have it in motion to show the complexity of the shape.
But is it actually moving?
In 4 dimensions, no. In 3 dimensions, we use motion to help show the extra dimension.
That helps. Okay, that helps.
Flatland?
Ooh.
We'll have to look into that.
Okay. That So Flatland, I think we're gonna check that out.
I need to get up and stretch. My
Okay.
back and hip are killing me. We're at the 1 hour mark.
So we'll be right back, guys. Okay?
Or yeah, we're gonna take about a 3 to 5 minute break. It's probably closer to 3, but I have to stretch. I tweaked my back the other day, so I gotta get up and move around. See you in 3.
BRB.
And we're back.
Are we back? Am I back?
You are back.
Check, check.
Yep.
Okay. I just couldn't remember if I took myself off of mute on my mic. So why? Why do we care? Why do we need this?
Okay, so he was talking about the book Flatland, where a guy lives in a 2D world.
Yeah.
There's actually a Futurama episode about it, where they're racing at light speed and they hit each other and they hit so hard to become a 2-dimensional object. So
is that the one where Fry becomes a cop?
Possibly.
Okay.
No, it's where the professor is racing.
Oh dear, that's concerning.
So what it is if we were 2-dimensional, right? We're trying to theorize, and I'm using 2 dimensions on purpose because you got 2 dimensions here. We're trying to theorize using visualizations and mathematics as 2-dimensional what 3 dimensions might look like. So if you were 2-dimensional, right? There could be 2-dimensional beings within the universe.
I was about to get into that.
Again, infinite.
Yeah,
but
they could be here now.
Exactly.
Because we can't see them because they would be flat.
And that's exactly why we need to understand 4 dimensions.
Okay.
What is in dimensions higher than that? Could we even process a 4-dimensional object if there was one in the room? Would we see it?
Is it possible that...
Oh, they are rotating, yes. They're turning.
Okay.
That's a very, very good point that I should have pointed out.
What the hell is that?
Oh, I don't know.
Okay.
So that is a rotating pentaract.
Okay.
I like how the pentaract seems to be better at visualization.
Yeah.
So pentaract and a tesseract are both higher dimensional. So 4th dimension's 5th dimension.
So is it possible?
Does that now make more sense?
Yeah, I still like the pentaract better. For some reason, it makes my brain hurt less. Is it possible that there are things that we can see currently that actually have an additional dimension?
So, okay, on that part of it, I understand the basic geometry of a tesseract or pentaract. I understand the mathematics behind it. I don't understand how they would physically manifest in our world. If they can, I don't know. It's all speculation and theory. But technically, I guess, from my understanding, my very limited understanding, is there could be a 4-dimensional object in the room with us right now. We can't interact with it because it's 4 dimensions, just like we couldn't interact with a purely 2-dimensional object.
Because technically, paper is even still 3-dimensional.
Yeah, paper, even the drawing on paper is 3-dimensional.
Right, because it does have the slightest bit of height. But
so that's a 2-dimensional representation in a 3-dimensional world, drawing on paper.
Right.
It's still not 2D.
Right.
So a 4-dimensional object might be able to see us, but again, I don't know how this works, so this is all conjecture.
Wait, okay. So technically, would the images on our screen be 2-dimensional?
No.
But they don't have depth.
They do. It's the photons.
Okay.
And there's another, doubling back to the slit experiment. One of the things they were trying to prove with the slit experiment is a photon a wave or is it a particle?
Right.
A wave technically is a 2-dimensional object.
Right.
A particle is 3-dimensional.
How?
A photon's both.
How is a wave?
It doesn't have mass. A particle has mass, a wave does not.
Why doesn't a wave have mass?
Because it doesn't have that 3rd dimension.
Are we sure?
That's another really...
Because that seems sus. I feel like...
The point of the whole wave versus particle thing is if a photon has mass,
Yeah.
right? If it is in fact a particle,
Mm-hmm.
how is it able to exist at the speed of light? How come? What happens with it at the speed of light if it has mass? If it doesn't have mass, general relativity doesn't necessarily apply with time dilation, which could explain why photons can get, in fact, to the speed of light.
But they can't.
But they can.
But you.
The speed of a photon in a vacuum is the speed of light.
Okay.
That's why they call it the speed of light. Photon is light.
Well, I know photon is light, but
so if a photon is a wave, it can exist at the speed of light without violating causality.
Okay, without needing to be in a vacuum, essentially.
Well, you can have, so some things do travel faster than the speed of light in not a vacuum.
Right.
Chekhov, the type of radiation.
Okay.
Chekhov.
Oh God. Cherenkov.
Yeah, Cherenkov radiation is light traveling faster than the speed of light for the volume it's in, which is water.
Okay.
That's why it's blue.
Because it's in water? Or because it's going faster than the speed of light?
Because it's going faster than the speed of light.
What makes it blue? Like,
I don't know. I really don't. It could be just the way it interacts with the water. It allows the particles emitted from nuclear fuel to move faster than the speed of light in water. These charged particles disrupt the water molecules in their path. Light particles, known as photons, are released, creating a visible shockwave or blue or violet light. So the blue reaction is something traveling faster than the speed of light in non-vacuum. And that's why the vacuum is so important. You cannot go faster than the speed of light in a vacuum if you have mass, because the amount of energy it would take to reach that speed is infinite, and time would slow down until it stops at the speed of light.
Okay, two things. Two questions.
This rabbit hole's gotten deep because now we're getting to the edges of my knowledge.
How fast would we die?
In that?
Yeah.
It's a nuclear reactor.
We would die.
Yeah.
Real fast.
Not pleasant.
Because my other thought was...
Although nuclear reactors aren't that complicated. It's hot rock make water boil.
Bubble.
Boil make spinny turbine go roundy round.
So would this be possible to use to make us go?
No.
Why
because
not?
It's through a medium. Go between stars where in a vacuum. Again, it's the vacuum that matters.
Okay. Actually in a vacuum. Like the whole thing is a vacuum, because I know that there's little nubbins of like it's not a vacuum. For all intents and purposes,
it's a vacuum.
And
some spots are denser than others, but it's just considered a vacuum.
Okay. So we would need like a tube of water to be able to.
And then only the photons, only the radiation can go faster.
Oh,
so
okay. So we wouldn't be able to power something.
So the blue light, think of it like a sonic boom for light.
Okay.
Because something is going faster than the speed of light in that particular medium, it is producing a light boom.
Okay.
So that's this radiation effect.
Okay. So is this like a photo or like a video? Like
there is a video of it.
Right. Okay. Is it consistent or just a boop?
I think it's just a boop when it first starts. I'm not certain. Let's check.
Super pretty.
Oh,
what the heck? Oh, it's PBS. That's why.
There it is. So I guess it's constant.
Okay, it's so pretty, and I feel like I'm gonna die looking at it. So, with the extra dimensions,
yes,
that gets into things like
I don't know how it's applied. Honestly, it's out of my wheelhouse.
Right. Maybe we'll have to do a little more research in the future.
Maybe do a deep dive on extra dimensional objects.
Yeah.
I know there's something like 24 dimensions or some shit.
Mm-hmm. Split it up. You take half the dimensions, I'll take the other half the dimensions, and we try to explain them as best we can. How many dimensions are there in Minecraft?
How many dimensions does the universe have? 4 in the observable universe.
Okay. Well, but how did we observe the
So,
fourth dimension?
okay, this is just defining it as 3 spatial dimensions and 1 time dimension. There are 26.
Okay.
Physical.
I'm bothered by the time dimension thing still.
Okay. 4-dimensional physical space-time plus 4-dimensional. This is fucking advanced string theory here. I am way out of. I'm not versed in string theory anymore. I was way into it in high school, but it changes like every year. 26 dimensions. 3 octonic dimensions. I don't even know what these fucking words mean.
Octonionic.
4-dimensional internal symmetry space. 8th first generation Fermi particles.
Christ on a cracker.
8 first generation Fermi antiparticles.
Huh. Okay.
I don't know. That's fucking complicated. A little out of my wheelhouse. How did we end up on 4-dimensional objects from fucking simulation theory?
Theory. Multiverse?
Yeah.
And
all 11 dimensions explained, but there's 26. It also.
Oh, it's 2021. That's why.
It also depends on your definition of the dimensions.
COVID created more dimensions. Every time you cough.
Oh, welcome to string theory.
Oh God, there's a super string theory.
Yeah, there's a bunch of different string theories. There you go. That should clear it up for you.
Yeah. Crystal. Thanks for that, Roy. Appreciate you. This is what my brain's doing right now. This one.
Yeah.
That's my brain right now.
11th dimensional universe. There's 11 physical dimensions. Is a 2-dimensional representation.
Right. Oh, is that a Klein bottle? Or is that the 11 dimensions?
So a Klein bottle is a 4th-dimensional object.
Okay.
It's a 3D representation of a 4-dimensional object.
Okay.
Because it passes through itself.
Can we pull up a Klein bottle? Because I love Klein bottles. And, okay, as long as we can keep to... Wait, so is a Klein bottle a tesseract?
So Klein bottle is a 4-dimensional representation of a 3-dimensional object. Wait,
right.
3-dimensional representation of a 4-dimensional object. Because it interacts with itself.
Right.
But it actually doesn't. A real 4-dimensional Klein bottle would not interact with itself. Why? It's a single solitary continuous surface all the way through.
Right.
But because we're making it in 3 dimensions, it has to pass through itself.
So it would just be...
There's a Klein bottle represented in 2 dimensions as a 4-dimensional object. Okay, it's a 4-dimensional donut. A Mobius strip, I believe, is also a 4D object.
Okay. So how is a Mobius strip a 4D object? Because I know that it is, but like it's...
Math.
But it's got... Is it because... Is the interaction with itself a dimension?
And it's because it is continuous. But no, there's...
I can...
From the surface of it, it is a continuous strip. So at one point or another, as you follow it, it's on the top, the bottom, the left, and the right. All at the same time.
Oh.
Is that a...
Okay.
It's hard.
Okay.
So hard to describe this.
So it's... Okay. So it's able to be in all of these locations.
There's a Klein bottle
simultaneously.
As you think about it, there's a Klein bottle. There's a 4-dimensional Klein bottle.
Okay.
These are the same shapes.
Okay.
There's a Mobius strip, which is a Klein bottle is 2 Mobius strips, and 4D is 2 3D Mobius strips.
Right. So the extra dimension is it being all of these places at once.
Yes, kind of. I think I might be tapped. My brain hurts. Trying to describe 4-dimensional objects. A 5-dimensional Klein bottle?
I don't know, but it's super pretty. I want one. Okay, so before we go out, because I'm good with being tapped right now. Can we watch a GIF of someone trying to fill a Klein bottle? Because I kind of love that and it fascinates me. Oh, I like this representation of the Klein bottle. Ooh, that's a really good one. Oh, that's wild.
See how it's continuous over every surface?
Right,
Unbroken.
right. Okay, but now I want to watch the like. I need the ant to come out.
Well, it's a GIF.
I know, I know. No, I'm not complaining at the GIF. Maybe I'm complaining at the GIF. I'm not complaining at you. I'm complaining at the GIF.
Some of these drawings are fairly sus.
Yeah, real sus. Klein bottle long.
Oh boy.
I'm kind of into it. Oh God.
Letting air into it.
Oh, that's a good idea. I wouldn't, because I've seen them do Klein bottle fills, but I've never seen them do it that way. That's a really good idea. Also, now I want to make a Klein bottle candle. Okay, guys.
I think we're gonna call it.
That was super fun, and we will be doing another episode very soon. We think we may have figured out a more effective way of getting episodes recorded.
More
And
consistently
yeah, more
recorded.
consistently. So let's go back to my notes because I found my notes. Look at me. So special, so professional. Okay, so you can find us on Twitter, X, whatever you want to call it, at WDDST Pod. We are on most podcasting platforms, especially Spotify, at We Don't Do Small Talk. We're still working on iTunes. One of us has got to get like a
Apple device.
yeah.
So that's probably not gonna happen.
And we'll get there. Make sure you subscribe, like, share, rate us, review us, that whole shebang. That helps us immensely.
Gotta feed the algorithm.
Yes, we are on Twitch at Royal Color Games 1. I have a Twitch too, but I'm never on it. We'll get to that eventually. If you want to support us and the podcast, we are on We Don't Do Small Talk on Patreon. There's bonus content. You get shouted out. Don't you, Escalator? Escalator is currently one of our patrons. And yeah, if you have episode ideas, join the Discord and drop them in the podcast page or email at us at wddstpod@gmail.com. Make sure you rate, review, and subscribe, and we will see you next time.